Okay, so we are start chapter number 3, force and pressure. Okay, so up to last lecture we have studied the pressure of a solid, pressure of a liquid. Now we have to see pressure of a gas. That part also we studied of pressure of a gas. Okay, now in this topic we have to see atmospheric pressure. Okay, so we have studied formula of pressure. Okay, pressure is equal to force upon area. Okay, pressure is equal to force upon area. That's simply called as a pressure. Now we have to see atmospheric pressure. Okay, pressure but due to atmosphere, that is simply called as a atmospheric pressure. We know our surrounding our surrounding to our earth, that is presence of various gases. Okay, that we simply called as a air. Okay, so these gases are exist near about, suppose this is a up to 16 kilometer, they are in somewhat dense condition. Okay, also this atmosphere exists up to 400 kilometer above earth surface. Okay, but as height increases, that gases goes on rare and rare, mean density of gas goes on decreasing. Okay, so these gases are present around the earth and it present up to 400 kilometer above from the earth surface. Now if we take one diagram is given, that is the one bar of atmosphere they given here, such like that. Okay, so this side, suppose this is earth. Okay, and they show here such a dots. As we go towards earth's surface, then density of this dots goes on increasing. Okay, it means what? What is its meaning? Simply, this bar we consider of atmospheric bar. Okay, these are all the gases which are present around the earth surface. Now we know this gases also has its mass. Okay, also has its mass. Then gravitational force act on that gases also. Okay, so due to the action of gravitational force, the heavier gases are stay nearby the earth's surface. Okay, so all the gases present here, the dense dotted line are the heavier gases as compared to these gases are present above here. Okay, so these gases are present up to 400 kilometer. Okay, up to 16 kilometer they are somewhat dense condition. Okay, but now as we go on height, the density of these gases continuously goes on decreasing as we increase height above the earth surface. Okay, so all these weight of gases are act towards earth surface. Okay, suppose we are staying on the earth surface, at that time whatever the gases present around us that apply force on us. Weight means simply what? Weight is nothing but the gravitational force act on an object. Okay, W is equal to M into G, that are we already studied. So whatever the weight of that gravitational force, that is nothing but the force. That is nothing but the force, and that they apply on the object present on the earth surface. So all gases present around us, they continuously apply force on us. Okay, and that force per unit area is simply called as a pressure. So simply we can say that the gases present around the earth surface that apply pressure continuously on us. Okay, and that pressure due to the atmosphere present around the earth, that is simply called as the atmospheric pressure. Okay, so first of all we have to Remember, what is atmospheric pressure? The pressure act on us due to the our surrounding environment, okay, or our surrounding atmosphere. That is simply called as the atmospheric pressure. We know all gases are present around the earth. They are denser near the earth's surface. They become rarer and very rarer as we go above from the earth's surface, okay, and their weight is also act toward downward side of the earth on the earth due to the gravitational force, okay. So heavier gases are present near the earth surface, and whatever the pressure applied by the gases which are present around the earth, that are nothing but the atmospheric pressure, okay. Now one atmospheric pressure is what? That is the 101 into 10 raised to 3 Pascal, okay. We know unit of pressure is Pascal, and whatever the pressure applied by the atmosphere on sea level, okay, on sea level, that is the one atmospheric pressure. One atmospheric pressure is what? The pressure applied by atmosphere on sea level, that called as the one atmospheric pressure, and one atmospheric pressure is 101 into 10 raised to 3 Pascal, okay, which is equal to 1 bar, okay, which is equal to 10 raised to 3 bar. This conversion also you have to remember, okay. One atmospheric pressure means what? 101 into 10 raised to 3 Pascal, which is equal to, which is also called as a 1 bar pressure, which is also called as a 10 raised to 3 millibar. Then 1 millibar is equal to 10 raised to 2 Pascal, that is the hectopascal, okay. So this conversion we have to remember, okay. Atmospheric pressure is always tells in bar or millibar, okay, bar or millibar, that are the unit generally used to tell us the atmospheric pressure. I already told you this atmospheric pressure depend on the height from the earth's surface. Suppose we are present on the ground surface, then all gases will apply force on us. So force is nothing but the simply pressure. Whatever the our area divided by that force, that simply will be pressure. So whatever the force, the pressure applied by the gases, that will be more when we are on the earth surface. Suppose we are go somewhat above earth surface, suppose here gases are very rarer, okay. So it means that whatever the pressure they will apply, that will be less as we increase further above height. So simultaneously pressure will goes on decreasing, okay. So we can, from that we can conclude that near the earth surface atmospheric pressure is high as compared to the height. Further as we go on height, similarly pressure goes on decreasing. So this graph will express us this pressure versus height graph, that gives us the, as we increase here height, okay, as we go, here is height, means here as we increase height, simultaneously our pressure goes on decreasing. For this much height we have that much pressure. Now suppose we increase height, now we go here, so our pressure will goes on decreasing. Further we are go here, then our pressure will get reduced, okay. So such a way that as height increases, pressure goes on decreasing, okay. So that part also you have to remember here in the atmospheric pressure. Atmospheric pressure is simply what? Pressure applied by an atmosphere on us, okay. Whatever the gases present around us, they apply pressure on an object that is present on the earth surface. And one atmospheric pressure is what? That is the pressure on sea level, okay. That is the one atmospheric pressure. This conversion you also have to remember. One atmospheric pressure is equal to 101 into 10 raised to 3 Pascal, which is equal to 1 bar, that also called as the 10 raised to 3 millibar. This 1 bar is equal to 10 raised to 2 Pascal, that is the hectopascal. And simply you have to remember this diagram. What? Atmospheric pressure versus height. As height less, okay, As height is less, our atmospheric pressure is very high. As we increase height, our atmospheric pressure goes on decreasing. Okay, due to the gases become rarer and rarer as we go above from the earth surface. Okay, so you have to remember that much part in this topic. Okay, next topic we have to see, that is buoyant force. Okay, so now consider a one simple example. Okay, we have a hollow plastic bottle. If we throw that hollow plastic bottle in and water, okay, at that time that bottle does not goes inside the water, means it does not sink. Okay, now also consider one example, that is hollow plastic ball. Okay, again what happened there, if we place that ball on the surface of water, at that time again that ball also does not goes inside the water, that float on the surface of water as like this. Okay, this is the hollow bottle and this is the hollow ball. Okay, if we both throw inside the water, at that time they does not sink in the water but they are float in the water. Now again take one example, that is if we fill bottle with water. Okay, suppose this is a bottle and we fill it with water. Okay, at that time again what happen, it will go somewhat deep inside the water. Okay, but does not go at the bottom. Okay, again it will be float in between the bottom and our surface of water. Okay, so such a way that here hollow objects, okay, means simply their mass is very less. Okay, such objects are easily float on the surface of water. Okay, we know it is due to the one type of force which apply liquid on an object, and that force is called as a buoyant force. Okay, due to this buoyant force, these objects are still floating on the surface of object. Okay, one very familiar example we have to know, that is when we are go to the swimming, at that time as we jump in water, then automatically we will come on the surface of water. Okay, so you will realize it when you will go to the swimming. When we try jump in and water, at that time automatically without doing anything we will came on the surface of water. There what happen, water, that is liquid, apply force on us. Okay, that is in upward side. Simultaneously gravitational force act on us in downward side. Okay, so that both two forces act simultaneously on us at that time. Okay, so due to this buoyant force, if we jump in water, we will automatically come on the surface of water. That force is nothing but the again buoyant force. Okay, so here we consider one bottle that is floating in between this water. Okay, it is not exactly at bottom and not exactly at the surface, so it is in middle, in between somewhere. Okay, so inside that bottle there is water present. Okay, means it has somewhat mass. Okay, water is here, means gravitational force, no doubt about that, will be act on that water. So the gravitational force act downwards towards the center of earth on this bottle. Okay, but now still this bottle does not go towards bottom. Okay, means this gravitational force should be balanced by somewhat force. Okay, and that force is nothing but the buoyant force, force of buoyant. Okay, due to this buoyant force, gravitational force get balanced. Okay, force of buoyant and force of gravitational will be get balanced here. That is why that bottle does not move towards downward side, because these both forces are equal and opposite. Okay, equal and opposite. So their resultant force will be equal to 0. So that is why this bottle is float on the surface of water. Now here, in case of this hollow plastic ball and hollow plastic bottle, what happened here? Again, force of gravitation is in downward side and force of buoyant is in upward side. Okay, again always remember that this buoyant force is always upward side and gravitational force is always downward side toward the center of earth. Okay, so here what happened in case of this, these are the hollow bottles. Okay, their weight is very less. Okay, so gravitational force act on that object will be very small. Okay, so in that case we can say that this gravitational force will be less than the buoyant force. Okay, so in such a cases when this gravitational force is less as compared to the buoyant force, at that time object will float on the surface of earth, because simultaneously gravitational force also act on an object. If that force is greater as compared to the buoyant force, then that object will be sink. Okay, but when if buoyant force is greater, okay, at that time that object will be float on the that surface of a water. Okay, so here in buoyant force you have to remember, okay, that this buoyant force is always act in upward direction. Okay, opposite to the gravitational force. Okay, if any object floating on the surface of earth, then we can say that their buoyant force is large as compared to their gravitational force. Okay, so how this buoyant force depend on some factor that we have to see now. Okay, so we have studied about the buoyant force. Buoyant force is a upward force act on an object when it is in liquid. Okay, so now this buoyant force depend on some factor. Okay, there are two factors. First of all, volume of an object and then density of a liquid. Okay, so volume of an object is a one factor. Suppose we take one small iron nail, okay, and if we try to drop it in water, then simply it is sink in a water. Okay, because its volume is very less. Okay, now consider one very big ship. Okay, their mass is also very large, but still that float on a water surface. Okay, because of what? Because simply its volume is very large as compared to the nail. Okay, so volume is the one factor that simply affect the buoyant force. As a volume large, buoyant force is also large. If volume of an object is very less, then simply buoyant force act on that object will be very less. Okay, so that is why such objects are sink in water. Now next topic is, that is the next factor, density of a liquid. Okay, so density is simply, we know, ratio of mass by volume is called as a density. If a density of a liquid is high, then buoyant force of that liquid is also high. Now suppose consider one very small, very familiar example of a swimming. We are swimming in the lake, okay, or swimming pool, and also we have to consider two cases. First of all, we have to swim in swimming pool, and second, we have to swim in sea. Okay, so you will find that it is easy to swim in a sea as compared to our swimming pool. Because of what? Simply there are density of seawater is high. Because of what? Simply there is large number of salts are present in seawater. That is why density of seawater get increased as compared to the water present in our swimming pool. So due to the increased density, when we swim in that water, due to that buoyant force will apply by water on us will be large in seawater, as compared to the water in a swimming pool. Okay, so here density of a liquid is a matter in case of buoyant force. If density of a liquid is high, then simply its a buoyant force applied by the liquid is also very high. Okay, then these two factors we have to remember about buoyant force. Okay, what? Volume of an object. If volume is large, then simply buoyant force act on that object will be very high, and also density of a liquid. So here density of a liquid is high, then what happen? That the buoyant force applied by that liquid on an object will be very high. Okay, so these two factors affect the buoyant force. Volume example you have to remember, that is small iron nail and ship. Okay, this small iron nail is sink in water, but ship does not sink because its volume is very large. Second is example of swimming density, in that it is very easy to see in seawater as compared to the water in a lake or our swimming pool. Okay, because here density of seawater is high due to the salt present in seawater. Okay, so these two factors we have to remember that affect in a buoyant force. Now suppose if you object place on surface of water, then that object will float or sink, or what happen about that object? How can we guess about that? Okay, we know this buoyant force is required for the floating of an object. Okay, then there are three cases should be arise. Okay, if mass of an object is greater than buoyant force. Okay, mass of an object is weight of an object is greater than buoyant force, then that object will be sink in water. Okay, when this weight is greater than buoyant force. Okay, then if this weight will be equal to buoyant force, then that object will be does not sink, okay, or does not float. Okay, so it will be present in between the liquid. We see example that a bottle of water is float as like this here in between, okay, of the water tank this. Okay, so when this force, weight and force of buoyancy are equal, at that time it does not sink or does not float. Okay, it stay in between that liquid somewhere. And third case, that is the if this weight is less than buoyant force, at that time object will float. Okay, so these cases you have to remember. If weight is greater than buoyant force, then that object will sink in a liquid. Okay, if weight is equal to buoyant force, at that time it does not sink or does not float, it will stay somewhat in that liquid. Okay, and third case, if this weight is less than buoyant force, means buoyant force, upward force is greater than the weight, at that time the object will be float on the surface of water. Okay, so these cases also we have to remember. So today we are studying about buoyant force. Buoyant force is what? It is the upward force act on an object when it is go inside the liquid. Okay, and how this buoyant force depend on, that is the volume of an object and also density of a liquid. If a volume is large, then buoyant force will be high. If a density of a liquid is more, then buoyant force act will be more. And these three cases, weight if less than, equal or greater than, that also we have to remember. Okay, so last topic of this chapter is remaining, that is the Archimedes principle, that we will see in tomorrow's lecture. Okay, thank you.